Hello and welcome to part 2 of the homework helper video for section 5.1. I just want to walk through this one. This is straight from your homework from section 5.1, and it's actually the same approach we used when we were doing derivatives. We're trying to find the indefinite integral or the antiderivative of this function, and a lot of students look at this and they say, oh my goodness, look at this. This is the quotient rule. We haven't done the quotient rule backwards, or we haven't been shown how to do the indefinite integral of rational functions like this where there's a quotient of polynomials. And the same shortcut that we used when we did derivatives of functions like this one we're going to use for antiderivatives. But it's been a while since we did that shortcut, so I want to show you what we would do. If ever the denominator is just a monomial when you're dealing with something like this, then you can split the numerator into into the individual terms and put it over the denominator, right? In other words, this integral is definitely equal to the integral of x squared over x to the fourth plus 6x over x to the fourth minus 9 over x to the fourth, right? dx, right? So then you can simplify this. You can say that this is x to the negative 2 plus 6x to the negative 3 minus 9x to the negative 4 dx. And then when we're doing the antiderivative, all we have to do is use the quotient rule. Just be careful, because we're doing, we're adding an exponent and dividing by the new one, right? So this is x to the negative 1 over negative 1 plus 6x to the negative 2, all divided by negative 2, minus 9x to the negative 3, all divided by negative 3. And don't forget your trusty plus c, right? One last step, maybe we would rewrite these with positive exponents and reduce the coefficients, right? So what we've got here is negative 1 over x, right? And this one will be negative 3 over x squared, right? That x to the negative 2 goes down to the denominator. Same thing with the x to the negative 3 and 9 over negative 3, so we'd probably make that plus 3 over x to the third plus c. Good. So now, what you could do to check this is you can always go backwards, right? You can always check these by taking the derivative of the original function and making sure you get something that's equivalent to this one, right? But that's good enough for us. That's what we're doing in this problem. So all of the tips and tricks, a lot of the tips and tricks that we use for taking derivatives can also be used for going backwards and taking antiderivatives. Just wanted to show you that one so it doesn't trip you up. I hope that helps. And as always, email me if you have